Right, good morning, good afternoon, good evening, class. This is Mr. Erosena, and today we're going to start our start our investigation of function operations, starting with sum and difference of functions. All right, so just as the title of today's topic suggests, we are basically going to add and subtract functions. All right, so functions can be added together, just like anything else, any other number, they can be added together because a function really is just an equation that returns a number. So, for example, let's say I have a function f of x. I can add that to a function g of x, and that'll give me a new function which we'll call h of x, like that. And it basically says that I just have two functions, f of x and g of x, and I add them together to create a new function called h of x. Sometimes we write it like this: f plus g of x is equal to a new function h of x. Okay. And that's basically what function addition is. Just taking two functions, add them together, create a new function, and we work from there. Okay. Now, one thing to keep in mind is that both of these are the same. So if I have f of x plus g of x equal h of x, it's exactly the same thing as f plus g of x equals h of x. They are exactly identical. Okay, I usually most likely just use the former, the f of x plus g of x equals h of x. It makes more sense to me, but some textbooks and some people will use the one on the bottom. And remind yourself that they are the same. Right, let's go through an example. So example 1. So here given f of x equals x squared minus 3 and g of x equals 2x plus 3, determine the addition of the functions f of x plus g of x. And then once you've done that, we'll determine the values of f of x, g of x, and then finally h of x when x is equal to 3. Alright, so let's do the first one. First part of the example says, let's leave it red. Okay, so what is f of x plus g of x? Right. Well, we just basically take f of x. We'll replace f of x with its function, x squared minus 3. We'll add to it g of x, which is 2x plus 3. And there we go, we're done. Obviously, we can simplify this a little bit because there's some terms that can be simplified. For example, well, the x squared and the 2x don't get simplified because they're not the same. But the minus 3 and the plus 3 can simplify, and they will effectively cancel each other out. So the combination of f of x plus g of x gives us this, x squared plus 2x. Alright, so there we've added them together. Now, on to the second part. Determine the values of f of x and g of x and h of x, because we'll say this is my h of x. That's h of x. Right. And we'll see what happens when x is equal to 3. Well, for f of x, that's easy. What is f of 3? F of 3 is just going to be 3 squared minus 3, which is equal to 6. G of 3 is going to be 2 times 3 plus 3, which is equal to 9. And then h of 3 is going to be 3 squared plus 2 times 3, which is equal to, if I'm not mistaken, that's equal to 15. There we go. That should make a lot of sense. Why h of 3 is equal to 15. Because remind ourselves that h of x is really just f of x plus g of x. So when calculate h of 3 is really just f of 3 plus g of 3, which we know f of x or f of 3 is 6. G of 3 is 9, and therefore h of 3 is 15. There we go. So it turns out that h of 3 is just the addition of what f of 3 is and what g of 3 is. Okay, and this is true for any addition of functions. Is you could add all the function terms together. So like for example, that's what we did here. Okay, we added all the terms together in this part to get this. Okay. And then from that we can calculate h of 3 like we did here to get 15. Alternatively, if you're just interested in a particular exact value, you can calculate f of 3 first, calculate g of 3 next, and then just add them together like we did here, and get that h of 3 is equal to 15. Yeah, so keep that in mind, because sometimes adding two functions together might be very difficult. It might actually be easier to evaluate one function at the value you're looking for, evaluate the other function at the same value, and just add them together. Okay. Graphically, what this basically means is that h of x, wherever graphically, again, you take just the two functions and you basically just add them together. And I can show you that sort of. There we go. Not those ones. But let's say x squared minus 3, we'll label this f of x equals, and then we'll have g of x equals 2x plus 3. Okay, so there's my functions, and I'll just say h of x. This is much easier to type it this way, f of x plus g of x. There we go. And as you can see, h of x, let's see, where is x equals 3. There we go. So here is h of x at x equals 3 is equal to 15. And it's basically taking the g of x value here of 9, the f of x value here of 6, and just adding them together to get this h of x value of 15 up here. Okay. So on a graph, this is what it looks like. It takes the two functions, adds them together, and then you get this graph. Okay. As you can see, h is basically has the shape of f of x, but we're adding to it whatever the value of g of x is. That's why it's slightly higher at all values of x. Okay. All right. Okay. Now, the difference of functions operates very, very similarly. Whereas the sum of functions is the addition of functions, a difference of functions is basically if I take one function and I subtract it from another function. This gives me my new function h of x. Okay. There's something you have to keep in mind with this one, though. It's not as straightforward as an addition of function, or an addition of functions, as you'll see in the next example. But the basic principle is identical. Okay. So, difference of functions. We just take one function, subtract it from another function. But that minus sign does some pretty interesting things to the second function. Right. So, here's an example. Given f of x equals square root of x minus 1 and g of x equals x minus 2, determine the difference of the functions f of x minus g of x. Let's do that first. So here we get f of x, which is root of x minus 1. And then we're going to subtract from it g of x. Now notice this is going to be slightly different from what I did with the addition of functions. Because remember, I'm subtracting the whole function, not just part of it. I have to subtract the whole function. That minus sign ends up when I remove the brackets, and I'll get the following. Root of x minus 1. I still get a minus x, but then that minus 2 becomes a plus 2 because I multiply the negative sign through. Right, there we go. So there's my function. That is the difference of the functions. A little different than the addition. That minus sign, all it does is yeah, that minus sign in front of the second function just changes all the signs of that function. So rather than being x minus 2, it becomes minus x plus 2. Now, is this the same as g of x minus f of x? Well, let's take a look. G of x is x minus 2. And then we're going to subtract from it, and again, use brackets, square root of x minus 1. So when we finish calculating it out, or simplifying it, get rid of the brackets, we get the following, x minus 1. So this one's g of x minus f of x. So obviously it's not the same. It looks kind of the same, but not really. So much like subtraction of numbers, if you switch the order, the result, the difference, is actually different. Okay, so keep that in mind. One thing I like to think of is, if I'm subtracting functions, I always think of it like this, minus g of x. Right, that's just to remind me that whatever g of x is actually inside a set of brackets, so that I can, especially if g of x is multiple terms like that. You just got to remind yourself that if it's multiple terms, put it in this form when you are subtracting functions. Otherwise, you're getting a lot of things wrong simply because you are forgetting that the signs of g of x will change. Okay. Now, one neat application of this is in waves. Because in physics, we deal with a lot of waves. And one thing that waves do is waves interfere with each other. They interfere in two ways. We call it constructive and deconstructive, or destructive. Constructive and destructive interference. Okay, what that basically means is that if two waves interfere with each other, they will either make the combined wave bigger, and that's what we call constructive interference, or they will work against each other and destroy the wave. And that's what we call destructive interference. Okay. Why is this important? Because in a lot of applications involving waves, one of the things you can do is either make a sound wave louder by interfering constructively with it, or you can make a sound wave lesser by making the sound waves interfere destructively. Okay? A great application of this is in noise-canceling headphones. A noise-canceling headphone will generate a wave that will counteract outside waves. Music amplifiers do the opposite. They will generate a wave that will cause the sound wave to become larger. So anyways, so here, let's determine whether these functions interfere constructively or destructively. Okay, so I've taken the liberty of already graphing the equations out for you. Okay, going back here, hide those. There we go. Okay, so here I haven't added the functions yet, and I'll delete these ones. I'll call this f of x, and I'll call this g of x. G of x equals. So how can we tell if these waves will interfere constructively or destructively? Well, let's take a look. Let's say here, or maybe here's probably the best one around here. Zoom in here. Okay, so here we have two waves. F of x is the black wave on top. G of x is the red wave on the bottom. So f of x has a value of 0.227. G of x is a value of negative 0.849. So the two waves are kind of not in the same position. One wave is positive, f of x is positive, g of x is negative. So these two are kind of opposing each other. As I move my line to the next point, let's say here, f of x is really positive, g of x is really negative. And it looks like at this point, if I add the two waves together, so the 0.8 plus negative 0.99, The resulting addition of the waves is going to make them smaller, because 0.8 plus negative 0.99 is going to end up being a very small number. Okay, and it's going to be pretty much the same throughout the majority of these two waves combinations, is that one wave is going to try and counteract the other wave. Okay, so let's see if that's actually what happens. So plot h of x. There we go. So there's h of x. H of x is the blue wave. So as you can see, the blue wave is actually smaller than either of the two. So it's smaller than f of x. If you notice, the blue wave never gets higher than f of x and never gets lower than f of x. While at the same time, it never gets higher than g of x, never gets lower than g of x either. So the resulting wave combination of the two waves results in a wave that is overall smaller at all points than each individual wave. If these were sound waves, then the resulting sound that's generated would be not as loud as either f of x or g of x. Okay. Obviously, you can manipulate these. Like, for example, if I change this to, say, pi over 2, we've manipulated it slightly so that the resulting h of x is bigger. Okay. Let's change it to just pi. Here, the waves are completely identical, so the resulting wave h of x is much, much bigger. Okay. Here, the waves are completely out of sync, and the resulting wave actually ends up being 0. Okay, so if these were all sound waves, this particular case would produce 0 sound, because the f of x sound wave is being completely cancelled out by the g of x sound wave. Okay, so depending on what you're looking to do, you can make the wave larger, you can make the wave smaller, or you can just completely destroy the wave. Okay? Now, where would this be useful? Well, again, usually in sound applications. If you want to make a really, really loud sound, you obviously want your waves to reinforce each other so that they become bigger. Okay, so think of like a tuner muffler, a car muffler that makes the car engine sound louder. The muffler actually, rather than this, the muffler would end up exhibiting a waveform like this, so that the resulting combined sound of the muffler and the car engine is actually louder. Okay, well, a proper muffler would probably want to do something like this, where it makes the muffler or the car super quiet. Okay. Other things we like noise-canceling headphones. Really good noise-canceling headphones will do this. Will have this situation where it'll cancel everything out, so all you hear is your music. While not so good quality headphones would probably exhibit, well, maybe not, maybe something like this, where the resulting sound wave is not as loud as the original sound wave, but not completely gone. So it should be like maybe like dollar store headphones as opposed to, say, like Skull Candy headphones. Okay. Right, so that's just one application of where adding functions has some use. But all it really does is just taking the functions, adding them together, and then creating a new function. Okay. All right. So that should set you guys up nicely to complete today's assignment. Okay. Good luck. Have fun. And if you guys have any questions, you guys know how to contact me.